All right, here we go. Unit 2, Section 5, Deductive Reasoning. Here we go, Sherlock. We're going to deduce some logical stuff. All right. Deductive reasoning is the process of reasoning logically and drawing a conclusion from a given facts and statements. In deductive reasoning, there are a couple of laws of reasoning that we use. One is called the law of detachment. When you detach something, you break it off. So when you're given a conditional statement, if the hypothesis, that's supposed to be a T or P, is true, then the conclusion, or Q, is true. This is it drawn in symbols. If P, then Q. I know P, therefore I know Q. And this little 3-dot symbol is therefore. A conclusion indicator is what that's called. Therefore, I know this. Use the law of detachment to give a valid conclusion. If not possible, write no valid conclusion or invalid. Would also work. All right, given, if Mark saves $30, so I'm going to say S for saves, then he can buy a new video game. Mark saves. So if S, then buy. If he saves, then he can buy. He saves. Therefore, he can buy. So our conclusion is Mark can buy a new video game. It doesn't say you have to put it into symbols, but man, it makes it a heck of a lot easier to figure out if it does work if you put it into symbols. The way I like to think of this law of detachment is if you detach the pieces, they only follow the arrow. So if you're given S, then the arrow sends you to B. So if S, then B. But if you have B, you can't go against the arrow. You don't know that's why you have B. It could have been another reason that you have the B. Maybe he got $30 for his birthday. Maybe he found $30 on the ground. You know, anything could have got him the chance to buy a new video game. But if he saved, he definitely gets to do it. If he gets to do it, it could have been another reason. So let's look at number 2. If a quadrilateral is a rhombus, so if a rhombus, then it is a parallelogram. P. Quadrilateral ABC is a rhombus. So if it's a rhombus, then it's a parallelogram. We know it's a rhombus, therefore it's a parallelogram. So A, B, C, D is a parallelogram. And we're going to talk more about those shapes. You should be familiar with them a little bit, but we're going to get to them later in geometry. But a rhombus is like a square that somebody just pushed sideways a little bit. Its sides are all the same. Its opposite angles are congruent. A parallelogram is opposite angles are the same and opposite sides are congruent. Rhombus, all of the sides are congruent, so then opposite sides are congruent. That's what happens there. Number 3, if you are 18 years old, then you can register to vote. So if you are old, then you can vote. Olivia is not 18 years old. So if you're old, then you can vote. She is not old. So can she vote? We don't know. She has to be, we just know that she's not 18. That doesn't mean that she can't vote, because what if she's 32? Then she can vote. So no valid conclusion. If you can't follow the arrow, you don't go. Let's check out 4 and 5. If the sum of the measures of two angles is 90 degrees, I'm going to go with N for 90. Then they are complementary, C. And then we are told the measure of angle J is 58 and the measure of angle K is 32. So we know N, if N, then C. Let's see, what is 58 plus 32? 8 and 2 is 10. 5, 6, 7, 8, 9. They are in, therefore we follow the arrow, we know C. Measure, or so not, we don't need to measure. Angle J and angle K are complementary. If you plan to attend prom, then you must purchase a ticket, T. Sarah purchases a ticket, a prom ticket, T. So if P, then T. T. You can't go against the arrow, so no valid conclusion. Maybe she bought it for someone else to go, not herself. So we don't know for sure. That is the law of detachment. If you have a detached piece, if you get the start, you get to follow the arrow. If you don't, you don't know. The law of syllogism. Yep, it's a funny word. Go ahead and laugh. Syllogism. This allows you to draw a conclusion from two conditional statements in which the conclusion of the first of the first statement is the hypothesis of the second statement. So if P, then Q, if Q, then R, therefore if P, then R. Basically, they are connected through these pieces. In math, we've talked about it already. It's called the transitive property because it's about equality. The equalness transfers through the thing they have in common because we can substitute one in for the other. And likewise, things happen here. So we're going to look for using the law of syllogism to give a valid conclusion. If not possible, write no valid conclusion. So let's look at number 6. If it is Saturday, that's a highlighter. Hold on. Boink, boink. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Let's go with P for pack. So if S, then B. If B, then P. Therefore, we can connect through the B's. If S, then P. So if it is Saturday, then Jake will need to pack his lunch. It has to be that diagonal connection. It has to be the end of one goes with the beginning of the other. So let's look at number 7. I think it's way easier to do if you do it in symbols, especially these because some of them get a little tricky. If a number is divisible by 12, let's see, I'll go with T for 12. Then it is divisible by 6, S. If a number is divisible by 6, S, then it's divisible by 3. I'm going to go with E, because 3's got a lot of E in it. So if 12, then 6. If 6, then 3. I got a linky. So therefore, if 12, then 3. So if a number is divisible by 12, then it is divisible by 3. These are getting long, so I'm starting to write them in symbols. Let's check out a few more. If a quadrilateral is a square, S, then it is a rectangle, R. If a quadrilateral is a rectangle, R, then it has 4 right angles, F. So if S, then R. If R, then F. We got a link. Therefore, if S, then F. So if a quadrilateral is a square, then it has 4 right angles. Let's check out number 9. If it is a sunny weekend, if it's sunny, then you will go boating, B. If it is sunny, then you will wear, we'll go W, wear shorts. So if I got if it's S, then it's B. If it's S, then it's W. I need a diagonal link, but I don't got one. I need another diagonal link, but I don't got one. Nothing. No valid conclusion. You can't take the fronts of two things and call them a link. It has to be diagonal. It has to be the end of one is the beginning of the other. Okay? If you shop at Target, T, then you will use your Target red card, R. If you do not use your Target red card, let's see, not R, then you will not get 5% off. So T, then R, not R, then F, not a link, so no valid conclusion. If it snows, then school will be canceled. Snows, canceled. If school is canceled, then students will need to make up a day of school. M. So if S, then C. If C, then M. I got a link. So S, therefore S, then M. If it snows, then the students will need to make up a day of school. It's an F, I promise. Okay. And those are the law of detachment and law of syllogism. Detachment is if you have a detached piece, if you get the front, it's like a waterfall or rolling a stone down the hill, follows the arrow, it goes down. If you get the back, it doesn't go up. If you get not the front, it doesn't follow the arrow. You have to have the front. The law of syllogism is a link diagonally. The end of one has to be the beginning of the other. And it doesn't matter if they tell you if Q then R and if P then Q, we still have a link. And so then it's then if P then R. That's okay as well, as long as the back of one is the front of the other. You can make a conclusion in that sense. All right. Here are the laws defined at you again. What you have to do here is determine whether the conclusion follows from the given statements by the law of detachment or the law of syllogism. So we'll say LD or LS. If it does, state which law was used, and if not, write invalid or no valid conclusion. But invalid's way faster. Let's write that, all right? So we're looking for LD, or we're looking for LS, or we're going to say nothing. Go ahead and give it a pause. Try the first 5. Let's see how you do. All right, if you didn't do it in symbols, I highly suggest symbols. It's way easier to follow than sentences. So if I drive over the speed limit, if I speed, then I get a ticket. I drove over the speed limit. I S'd. And it's saying I got a ticket. So if S, then T. S. Therefore T. Is that true? Yes. And which one does it look like? LD. It's true. If Amanda goes to the restaurant, R, then she will order a hamburger, H. If she orders a hamburger, H, then she will get fries, F. Amanda goes to the restaurant, R, and then she will get fries, F. So R in, if R, then H. If H, then F. Therefore, linky in the middle, R, then F is what they're saying. Is that true? Yeah, it is. It's the law of syllogism. You can link through that. If it snows, S, then I will wear my snow boots, B. If it snows, S, then I won't go to school that day. What do we want to do for school? I'm going to do a K for school. Why not? S, then B. S, then K. Therefore, my conclusion is if I don't go to school, if I don't K, then I will wear my snow boots. Then I will B. If I not K, then I will B. Well, no, that's invalid. You can't say that. Okay, that don't work. Because there's no linky there, especially to go to not. Oh, let's see. I won't go to school that day. I won't. I don't K. So that'd be don't K. Yeah, but these are fronts. You can't link through fronts, so you can't get that. Okay? If Tina goes to the beach, B. Then she will wear sunscreen, S. Tina goes to the beach, B. Therefore, she will wear sunscreen, S. Well, B, then S. We know B. Therefore, falling downhill, we know S. That is an LD, law of detachment. If you get a cold, C. Then you should eat chicken soup, S. You ate chicken soup. You must have a cold, C. If C, then S. You S. Therefore, C. The arrow points from C to S. You know S. Can you go backwards? No. Invalid. Now, something to be said of that. If we knew C, then S, and then we said not S, could we say not C? Would that be a thing? You must not have a cold. You didn't eat chicken soup, so you must not have a cold. That's actually a thing. Because if you get a cold, you'll eat chicken soup. If you don't eat chicken soup, you don't have a cold. Okay? You can not the end and therefore no, not the beginning. Because the beginning makes the end happen. If you don't do the end, then you didn't do the beginning. That's actually a logical way to think. Okay? But you can't say not the front, therefore not the back, because maybe something else made you do the backside. 6. Couple left. 6, 7, and 8. Give them a try, and then we'll talk about number 9 together. All right, here we go. If two angles form a linear pair, L, then they are supplementary, S. If two angles are supplementary, S, then their measure is 180. measure. So if L, then S. If S, then M. Therefore, if two angles form a linear pair, L, then the measures are 180. L, then M. That actually follows. We got the Lincoln diagonal. So that is a law of syllogism. Okay? And we use SYLLOGISM. Law of syllogism. You want to do the law. There we go. If Kaylee gets at least a 95 on her final exam, let's see. If we get a, we'll do an N for 95. She will get an A in geometry. I'm going to go with an A. Kaylee got a 98 on her final exam. She N'd. Will she get an A? Yes. So if N, then A. She N'd. Therefore, she A'd. That is actually correct. That's the law of detachment. If it is raining, R. You must bring an umbrella. U. You bring an umbrella. U. It is raining. R, therefore you. If R, then you. You know you. Therefore you know R? No. Invalid. You can't go against the flow. That's not how it works. R, then you. Okay. Number 9, new rules. Use the law of syllogism to write 3 conditional statements that can be formed from the following true statements. So, I need you to pick 3 different answers. And I'm going to come up with 3 and I'll show you what I get. But you need to use this law of syllogism. You need to connect the ends. What I would do is go through and mark all of these with letters so that I can see which letters connect to each other. On your mark, get set, go. All right, let's see. If it's a square, then it has right angles. Ooh, that's a bad one. Let's go with 4 right angles. How do I want to do right angles? Let's see. Let's say A for angles. There we go. If a quadrilateral is a rhombus, then its opposite sides are parallel. If a quadrilateral has 4 right angles, ooh, I did that with A before, then it is a rectangle. I'm going to do a Q, because you can also call a rectangle a quadrangle, like a triangle, but instead of 3, it's got 4, quadrangle. If a quadrilateral is a rectangle, Q, then its opposite sides are congruent, C. If the opposite sides of a quadrilateral are parallel, P, then it is a parallelogram, G for gram. All right, so in this one we've got S, then A. We've got R, then P. We've got A, then Q. We've got Q, then C. And we've got P, then G. So we need a front and a back that are same. The first one that I see is S to A and A to Q. So if a quad is a square, then I'm going to connect it all the way down to Q, and Q is, it is a rectangle or a quadrangle. All right, so we used that one. Let's check another. Let's see what we can come up with here. I got A, then Q, let's see, I got an A and a Q and a Q and a C. So A, then Q, and a Q, then C. So A was, if a quad has 4 right angles, 4 right angles, then we can connect through the Q's, law of syllogism, to C, then its opposite sides are congruent. And let's see, the last one. I see a P here and a P right there. So I could do R to P and then P to G. So if a quad is a rhombus, then we're going to connect through the P's to get to G. It's a parallelogram. It is. There you go. A parallelogram. Boom. 3 different law syllogisms there. I mean, you could probably do it with a highlighter if you wanted to. You could say, like, this is an A, that is an A, this is an S, there are no more S's, this is an R, there are no more R's, this is a P, that is a P, this is a Q, that is a, nope, that's a G, that is a Q, a C is by itself. I'm running out of colors. Oh, there's some. There we go. Okay. So you can do purple to purple. You can do pink to pink. You can do yellow to yellow. Those are your front to backs that are colored. So you could also do it color coding, but I just like doing the symbols. I think it's easier. But that is the law of detachment. One detached piece, if you get the start, follow the arrow, you get the end. Otherwise, no. You can also do not the end, therefore not the front. That's another way that can happen, because if you don't do the end, you definitely didn't do the beginning. Because if you did the beginning, you would have got the end. Law of syllogism connects through the diagonal. One end has to be the other's beginning. And that's all. That's deductive.